So if anybody don't know about operators are a pretty cool idea in the Kubernetes world. Nobody wants to get up and log into a cloud by hand, manage your things by clicking and pointing in a cloud. There's no way you can scale that over time. So the idea is you take your day-to-day activities, you write a script or an Ansible playbook, and that could be in Python, it could be in Go, it could be an Ansible playbook, and then you set up some kind of an event trigger way, such that you would know what task to trigger, what task to fire based on what's happening, and you set up these rules. So in our case, we have just basic rules to say, once our containers are deployed, we're going to run these Python functions here, and these Python functions could be anything. So in my case, I'm adding new layers to my containers because I like to deploy vanilla containers. And once the containers are deployed, and then I can start to basically add complexity to them as part of my operator. So the idea is I'm not deploying full-blown built images. I built simple images, I deploy them, and once they're deployed, I start adding layers to them to get them to the place I want, and that's basically what the operator is doing. Right? It's a fancy way to have very thin, images, but when those images are deployed, you could biff them up with layers upon layers of complexity, depending on your infrastructure. So let's be patient while this is running. Let me take a look here again. So we're still running. Okay, so we're installing a few things. So, pip is running. Okay, so chamcraft pack command is running. Okay. Okay, it's still running. The packing is still happening. So just keep an eye on the processes right here. This one is very busy. Okay. So at least they're churning along. They're doing work. So, it's moving along. Expand this a little bit. We're still packing. Okay. So we're still here. Pack operator. I give it 9,800 seconds to run, and I check on it every 15 seconds. Because what I noticed the other day, so if I'm just typically running the end-to-end deployment, when I go to pack the operator, it takes a little bit, but not that much. But if I'm streaming, for some reason, when I'm streaming on the same laptop where I'm actually doing the packing, because of the competing for resources, that usually will take a little bit longer. So what I had to do to get away from this getting timed out is basically I bumped this up to some ridiculous number like 9,800 seconds, just to be safe, just to make sure that it actually eventually runs and not time out. Okay, so that's why I put this 9,800 seconds here, and I pull it every 15 seconds to see if it's completed or not. But obviously, it's still running. So typically the way I get around that wait time is I come over here and I say, okay, what does the CPUs look like? Okay, they're all busy. Some of them it's 100% busy. Okay, and I say, okay, what is my load average? Okay, so we're not heavily loaded yet because we're still packing the operator. We have not actually deployed the services yet, but once they start to get deployed, you start to see the load average increases because there's more containers being deployed and more services are up and coming and running. So it takes a bit of time to get there. So let's just be patient. So we've consumed 1.65 gram, 1.65 gigs of RAM. So that leaves us 17 gigs unused. So we're very early at this point. So we're not taking a lot of memory. A lot of the work that's being done right now is just crunching data to pack the code into a container. So that's why we see most of the work is happening on the CPU level. This is still running. Let's be patient with it. While that's happening, let's go over here, take a look at Kubeflow. So what we're trying to accomplish basically is this pipeline here, right? So we want to be able to run pipelines like this, and that's basically why we're deploying Kubeflow. The idea is we'll be able to do data science experiment where we identify problems, we collect data. In my case, what I want to do, I want to collect logs from all my services. So the idea is each one of these components here, from boot, networking, storage, compute, user interface, all of this would be logged. All of these containers will be producing logs. Those logs will then be pulled into a Kubernetes framework like this that is basically called Kubeflow. Those logs we'll choose the appropriate machine learning models to model those logs. We use tools like Jupyter notebooks, day-to-day data science, looking at the logs, manipulating them, learning the best ways to model them, and then coming up with hyperparameters and fine-tuning our models. And then basically get into a production phase where we have models that we can use in production. And over time, those models also get improved and better. So it's an endless loop of learning and improvement, right? So the idea is we should be able to generate logs. We're done packing. Okay, sweet. The packing is done. Okay, so what we're doing now, we're actually deploying Kubeflow itself, right? So let's go here. So we're done with this stage. Awesome. So now we're actually in the converge stage. So if you look over here, this is our converge stage. So we're deploying our dependencies. So our main dependency is the Kubeflow, right? So what we first do, we create a model for Kubeflow. We come here, we deploy Kubeflow. So that's what's happening now. So if I go now here, let me get out of this screen. If I do kubectl get pods, kubectl get pods. Okay, soon I should. Okay, so you could see here Kubeflow. There's a namespace for Kubeflow now. So soon we should start to see those services coming up, right? So Kubeflow is still getting deployed.